Hi, I'm Steve Rohr, and I'm here with Marco Wolf, who is our manager of advanced engineering for automotive sensors. And I'm here with Dr. Robert Whittaker, who is our director of consumer sensing market vertical. And we're here at Electronica 2014 to talk about smarter sensors for an increasingly connected world. Marco, Robert, great to have you here today.
Great to be here, Steve.
Yeah, great day.
Yeah, fantastic. Thanks. So, hey, to get us started, a few weeks ago, our Chief Technology Officer, Rob Shattuck, he spoke about the Internet of Things. And I couldn't help but notice in Rob's discussion that the term sensors was quite pervasive. Yeah, it came up quite a bit. Can I ask each of you, and I think, Marco, I'll start off with you, if you could, maybe from an automotive perspective, if you could talk a little bit about your take on sensors and the Internet of Things.
Yeah, the Internet of Things is the first thing in automotive is containing a lot of sensors already, and it's connected to the Internet already. So if you think, or if you wish, it's probably one of the first things connected to the Internet. And so the sensors are connecting in the today's world still inside of the cabin of the car. So you have a lot of sensors in the passenger compartment, in the engine compartment, and motor control, drivetrain. So a lot of sensors there. But what is starting now, it's to communicate to outside, to share information of speed, acceleration, turn left, turn right, intention for the next crossing, and to have car-to-car communication, but also you share information with the Internet to make life easier, to navigate, find places you want to go there faster, and then end. So the Internet and the car is merging already, and it will be for sure a huge opportunity also for sensors to participate this trend.
Fantastic. So a lot of exciting things in the automotive world, but what about the rest of our world? Robert, if you could give us some comments around the rest of our lives.
Yeah, I'd be glad to. So I view things more from a consumer perspective, and people, where they start to have internet, they see it in their homes is with the computer being connected up, set-top boxes. Now we're actually having things which are not the computer, which are being connected to the internet. So people are starting to get used to that idea, being able to control things remotely. So for instance, if you're at work and you want to turn the air conditioning on at home, so when you come home it's nice and cool, you could do that from your smartphone, or it's hot, or for instance, you get an alert that something's happened at home. It gives you a chance to check and see what's happening on that. So we're starting to see those sensors going into the home, and people are getting a lot more comfortable with the fact that these sensors are giving them useful information, because we're bombarded today with so much information. Really, we want to filter off what's useful.
Fantastic. So if I hear you both correctly, so from the minute I wake up to the minute I go back to bed, there's an opportunity here that we're going to be connected, and that sensors will be with me in my whole lives. And Marco, if I heard you correctly, it was specifically in the automotive case where the network has always been defined kind of within the sheet metal. That network now, with a modem or some communication out of the vehicle, now connects to that whole world. The network is now our universe, and that network is not just confined to a car, but Robert, as you talked about, it now is our home, our work life. It's really everything that hits there. So that's a great start for our discussion, right?
Yeah.
So there's a lot of great things happening. So if I can, Marco, I'll start with you. Let's talk specifically on the automotive side, if we can. If you can help me and help our audience, understand a little bit about where sensors are playing their role today in the vehicle. I think a lot of people don't realize how many sensors and what kind of effect that has within our cars.
Yeah, the sensor world in automotive is, as I said, manifold. You have the engine control, everything to make the engine most efficient. And green means exhaust treatment, reduction of CO2, all of these need a lot of sensors. For example, to run a combustion engine very efficient, you need to know exactly at every load line of the motor the exact ratio between fuel and oxygen. And you have a bulk of sensors doing that job. You have the turbocharger, you have the intake manifold, you have then in diesel engines even exhaust recirculation to reduce the oxygen content without reducing the pressure of the load.
Right.
So you have many control loops to organize that. And if you have then residual burnable or oxygen gases, you have the catalysator, you have the particle filter in diesel, and the particle filter needs pressure sensors to see the load, and finally the after treatment of the nitrogen oxide. You need to add some, add blue, and all of that is a very, let me say, sophisticated network of sensors already. But this is only engine. If you look at the drivetrain, safety, stability control on the car, accelerator meters and speeds, ground speed measurement, and they're starting now to think of road condition sensor to see, is the road icy or is it rough? Do you have some issues with it in front of or before you get the impact of it, blocking wheels or something else? So a prediction of a safety case is, for example, something which is also important for the migration path from assisted drive to autonomous drive. And it's fun. The bandwidth of data transmission within the car is exploding with having the lidar, the radar, the optical, the infrared. So all of the front and surround view systems in the car is generating massive of data, which have to be processed in the control unit. But the funny thing is, if you think in autonomous drive, also sensors are required. We never thought about it. If the car is taking over responsibility, it has to give the responsibility back to the driver in any uncertain situation or in any critical system case. So the car has to make sure that there is a driver. He is awake. He's not distracted. And he's not dead. So live monitoring of the driver is something which is required to make autonomous drive, for example, happening on the road. So you have quite a lot of opportunities.
So those are some fantastic points. And I'm going to want to come back to some more automotive discussion here and talk about some of the smarter piece, but I want to address it back to you, Robert. So if you can help along that same side here with the non-automotive pieces, some of the ways that sensors are, pervasive in our lives today.
Okay, well, to come back on your earlier point that you're being monitored from when you get up in the morning to when you go to bed at night, in actual fact, you can be monitored from when you go to bed at night until you get up in the morning, because we're working with several companies where we're using technology that we have to analyze your breathing rate, your heart rate, your movement. From these things, they can calculate your depth of sleep, your points in the sleep cycle where you're sleeping most efficiently. And in the morning, they can say, okay, you had 7.25 hours sleep. You had your deepest sleep maybe at first half an hour after you went to bed, but you were quite restless. So they can give you pointers that maybe it's better for you as a person to go to bed a little bit earlier at night and get up earlier in the morning, because your body has a natural sleep pattern which falls into place.
Fantastic.
There. That's the kind of thing that we're doing. And of course, fitness is one of the things that everybody's talking about, and fitness more in the context of wellness, because I think we're in a society now where people are having to look after their own health. They can't rely on everybody else doing it for them. So many people, they see the wearable as a way of monitoring their conditions, and particularly if the conditions are changing. If there's a little slight subtle adjustment that they may have not noticed, but if you look at the data from various sensors combined, you can say, okay, that something happened here. That's a warning signal or trigger for them to investigate a little bit further. So there's a lot of research going on in that area. People are taking that ownership, and it's really a very, very interesting development that we're seeing in the industry.
No, it's fantastic, right? Just some great opportunities here. So Marco, turning back to the automotive piece and maybe building off, you gave us some examples around some new safety aspects, some fuel economy, clearly some of the mega trends. We talk about, and really the theme for our discussion today is around smarter sensors in a more connected world. So can you speak a little bit to the smarter aspect and what is it that we're really talking about when we talk about smarter sensors?
For me, a smarter sensor is going a bit beyond the pure measurement and providing data of the sensor. To ensure a safety level in the car, you have to provide more than only the data. You have to provide also diagnostic values. You have to make sure that the reading is and the measurements are right and there's no mistake in it. So smart sensors take part of the system function. They probably talk to other sensors. Hey, if I know your temperature, I can compensate my signal and make a temperature compensation. Or if I know the readings from the other neighbor sensor, I can improve my function. So there's no need in the future probably to have always a master control unit doing all of the algorithm. You can relocate some part of the algorithm into the sensor head and make the pre-computing there. So let me say, like a human body, a reflex coming from the knee is not passing till the brain. It's pre-processed already in the backbone. And so you react before it gets recognized in the brain. And this is how smarter sensors can work also in the future, that you have a pre-conditioning already and providing not the data, providing the information. That is the change which happens in smarter sensors.
Ah, that's fantastic, and a great example as well onto how we hit that. And so we had a similar question for you, Robert. And we talked about before the sensors and how they play a role in the complete system, right, and the fact that everything we're talking about is a closed loop control system,
right,
and the fact that our sensor provides that closure of that loop, that feedback mechanism. So in non-automotive applications, what do we mean by smarter sensors, and how does it play into that type of system control?
Well, I think that the sensors themselves enable you to sense some kind of variable, and then based on sensing that, you can control something. So what you'd want to do is sense a condition, and then maybe, let's say the temperature is too high, turn on the air conditioner, check you've turned on the air conditioner by seeing the temperature drop. So you've got this feedback loop. And I think it's very important with these networks that they're not just a transmit only, but it's a transmit and receive. So there's a lot of discussion about mesh networks and bidirectional networks. So you can be absolutely sure that when you've started to do something, you've initiated something, that you have really initiated what you thought you had. That's something that you see.
Ah, fantastic. So to go with this mesh network discussion, and Marco, I'll turn toward you, and actually some discussions we had at the electronics conference yesterday here at Electronica, the notion around sensor fusion. We hear that quite a bit. And can you speak a little bit in the automotive world of, maybe a simple example, but when we talk about, I think it ties to this mesh network concept, the notion of sensor fusion.
I think sensor fusion is strongly needed when you really have safety critical issues, and you can never rely on a single sensor. It can be misguided, or it can be even spoofed by any effect. So you need to merge two information coming from two different systems, and to improve the quality of the sensor. For example, the front video system, to make any crash avoidance, is using the LiDAR and the radar information, merge them together. In case of fog, the optic will probably fail, but the radar is still working. And so you can improve the total function combining these data. So whenever you are on different physical interaction with physical layers, you can dramatically improve the function. And this is nothing else than like in the past, the heterogeneous redundancy. It's exactly that you merge different aspects from the same theme to improve the data and the information.
So it sounds like there's a couple of benefits you described. One is around just enhancing the performance, right? Two sensors, different types of technologies merged together can give you a better solution, or a better determination that you made from that sensing piece. The other one is the notion of some level of redundancy for safety critical things of that nature. Similar in the non-automotive space, any places we see some of that.
There's some redundancy you can have by having additional sensors. If you're monitoring, for instance, a home environment, if you've got two temperature sensors or throughout the house, you can see if they're all giving a regular pattern, and you can be looking at the historical trend as well. So there is some of that. It's probably less critical for the home than it is for an automotive application.
Yeah.
But nevertheless, there are some applications there too. For instance, if you turn on your oven from home, and you want to plan to go and be there, and then your car breaks down, and you want to turn the oven off, you want to make sure that when you turn the oven off, it's gone off and you don't come home and your house is burned down. That's the kind of reliability that you're going to want to have from sensors, which is a lot to do with the communications network you've got in place to do that.
And parallels the live driver sensor you
Exactly.
described too, right?
Exactly.
You know, those things. So yeah, those are some phenomenal points. So with that, you guys have really got me excited, right? There's just some amazing amounts of, you know, technologies and possibilities for the future. And in our discussion here, and similar with other colleagues, it sounds like we've got a nice plan, and all sounds doable. But we know there are challenges ahead of us and a lot of work to be done. So if I could take the liberty to ask you to get out your crystal balls, to predict a little bit of the future, what do you see as, maybe it's a twofold question, and Robert, I'll start with you on this one, since I've been starting with Marco. You know, some questions around, you know, some challenges to see this as reality, as well as maybe something that might surprise us in the future.
Sure. I think one of the things is that in environment that I see, there are a lot of sensors which have to be battery powered. So they need to have a very, very low power radio link if they're not going to be installed with cabling. And the other thing is, if you do have a lot of these sensors and they are battery powered, somebody's got to change the battery. So how do you go to the next step and eliminate the need for having to change the battery? So areas such as energy harvesting, using things like the sunlight, solar cells, generating electricity so you don't have to replace these batteries. I think that's going to be something which is going to enable a lot more applications. Another thing is that today's wearables, they really are wearable, but you can see that you're wearing them. I think the trend of integrating these sensors into wearable fabrics so that a wearable really looks like something, you don't even realize you're wearing it, it's not obvious you're wearing it. I think that's going to be very interesting to see how it evolves in the future.
Yeah, fantastic. And Marco, how about from your perspective?
In automotive, one challenging is the number of sensors are rising, but the total cost of a car, so the cost pressure is high. This is one point, but the really challenging problem is the more sensors you need, you have limited number of power lines, limited number of signal lines in the car. The physical limits to integrate all of these cables in the car is already reached. So what you need really here is a more intelligent solution to communicate between sensor and the control unit, having less wires, using less power, maybe a communication over power line. Wireless is something, sounds interesting, but automotive is critical for that, because you need the sensor data all the time. No transmission from outside shall disturb any discussion between sensor and control unit. And so wireless is also a point for some function, but most of the sensors, safety critical sensors, are still wire-based, and we need there better solutions, higher density of information.
Fantastic. Well, sounds like, gentlemen, the future here is quite bright for us, very exciting, with its challenges to get us there. But I think in you and your team's capable hands, we will be very successful. So with that, Dr. Whittaker, thank you very much, for you. And Marco, thank you for participating. And I want to thank everyone on our Google Hangout for joining. And again, for those of you that can join us live here at Electronica 2014, please do so. And if you can't, please go ahead and download our app and join us virtually to join have the experience. So with that, thank you.